Good morning everyone, I'm Kimberly Anino from BSED Math 3A. Today, we will tackle about rational numbers.
So let's have first our learning outcomes. Take the challenge. In this lesson, challenge yourself to attain the learning outcomes. First, define and illustrate rational numbers. Second, solve problems involving addition, subtractions, multiplication, and division of rational numbers. So before we start to our lesson, let's have first an activity. Our activity is called Ramble Me. So our mechanics, you will first be given a group of letters that must be jumbled in order to form the correct word. Then you will guess the words and raise your hand if you know the answers. So let's start. Arrange the letters to form word. Number 1. A number that is expressed as the ratio of two integers where the denominator should not be equal to 0. That's right, rational. How about number 2? A fraction is the number of equal parts the whole is divided into. It's the bottom number of a fraction. Correct, denominator. Let's have number 3. A number that cannot be expressed as a fractions for any integers. That's right, irrational. So next, a fraction is the number of parts of the whole. It's the top number of a fraction. That's right, numerator. How about the last number, number 5? A number with no decimal or fraction part, and it includes negative and positive numbers, including 0. That's correct, integers. Now let's proceed to our lesson, which is rational numbers. So what is rational numbers? When we say rational numbers, it can be defined as any number which can be represented in the form of p over q, where q is not equal to 0. P is an integer, the numerator, and q is a non-zero integer or not equal to 0, the denominator. How to identify rational numbers? To identify if a number is rational or not, check the below condition. First, it is represented in the form of p over q, where q is not equal to 0. Then the ratio p over q can be further simplified and represented in decimal point. And we also have here the set of rational numerals. First include positive, negative numbers, and 0, and also can be expressed as a fraction. Types of rational numbers. The different types of rational numbers are given as follows. First, integers. Any integer can be converted cleanly into a fraction, like negative 2, 0, 3, etc. are rational numbers because they can express as a fraction such as negative 2 over 1, 0 over 1, and 3 over 1. Next, we have fractions, whose numerators and denominators are integers like 3 over 7, negative 6 over 5, and etc. are also rational numbers. Last, we have decimal. A decimal numbers that can be written as a fractions. We have terminating and non-terminating decimals. When we say terminating decimal, this means that the digits of after the decimal are finite in number. It is a decimal that has an end digit like 0.35, 0.7116, 0.9768, and etc. These are rational numbers. While non-terminating decimal with some repeating patterns after the decimal point, such as 0.333, 0.141414, and so on, and etc., are also rational numbers. These are popularly known as non-terminating repeating decimals. The difference between rational and irrational numbers. Rational numbers is a number that is expressed as the ratio of two integers, where denominator should not be equal to 0, while irrational numbers cannot be expressed in the form of fraction, such as pi, because pi is a real number that cannot be expressed by a simple fraction. Rational numbers are terminating decimals, but irrational numbers are non-terminating and non-recurring, meaning when written as decimal numbers do not terminate nor do they repeat. Examples: identify each of the following as irrational or rational numbers. Number 1 is 3/4, number 2 is 90 over 12,007, number 3 is 12, and number 4 is square root of 5. Since a rational number is the one that can be expressed as a ratio, this indicates that it can be expressed as a fraction wherein both denominator and numerator are whole numbers. So for number 1, 3/4 is a rational number as it can be expressed as a fraction and it can be expressed also as a decimal, where 3 divided by 4 is equals to 0.75. So number 2 is 90 over 12,007 is also a rational number because it can be expressed as a fraction. And for the number 3 is 12, also written as 12 over 1, again a rational number. And for the last number, 4, value of square root of 5 is equals to 2.2360679775. It's a non-terminating value and hence cannot be written as a fraction. So it is an irrational number. Next, we have the standard form of rational numbers. The standard form of a rational number can be defined if it's no common factors aside from one between the dividend and divisor, and therefore the divisor is positive. For example, 12 over 36 is a rational number, but it can be simplified as 1/3. Common factor between the divisor and dividend is only 1. So we can say that the irrational number 1/3 is in standard form, where 12 is the common factor given 12 over 36 divided by 12 over 12 is equals to 1/3. Now let's move on to positive and negative rational numbers. As we know that the rational number is in the form of p over q, where p and q are integers, also q should be a non-zero integer. The rational number can be either positive or negative. If the rational number is positive, both p and q are positive integers. If the rational number takes the form negative p over q, then either p or q takes the negative value. It means that negative p over q is equals to negative p over q is equals to p over negative q. For examples, in positive rational numbers, if both the numerator and denominator are the same sign and all are greater than 0, for example, 12 over 17, 9 over 11, and 3/5. While negative rational numbers, if the numerator and denominator are opposite signs and all are less than 0, for example, negative 2 over 17, 9 over negative 11, and negative 1/5. Our last topic for this lesson is the operation on rational numbers. In math, arithmetic operations are the basic operation we perform on integers. Let us discuss here how can perform these operations on rational numbers, say p over q and s over t. First is the addition. When we add p over q and s over t, we need to make the denominator the same. Hence, we get pt plus qs over qt. So for example number 1, 1/2 plus 3/4. So our formula is PT plus QS over QT. Then our given are P is equals to 1, Q is 2, S is 3, and T is 4. Then substitute the given formula. So our P is equals to 1 times T is 4 plus Q is 2 and S is 3 over Q is 2 and our T is 4. Then multiply 1 times 4 is equals to 4 plus 2 times 3 is equals to 6 over 2 times 4 is equals to 8. Then add 4 plus 6 is equals to 10. Then copy the denominator 8. Then simplify 10 over 8 by dividing both sides by 2. So 10 divided by 2 is equals to 5 and 8 divided by 2 is equals to 4. Therefore, 1/2 plus 3/4 is equals to 10 over 8 or 5/4. So we have also example number 2. So 2/5 plus negative 3/4. So our formula is PT plus QS over QT. So our given are P is equals to 2, Q is equals to 5, S is equals to negative 3, and T is equals to 4. So substitute the formula. So our P is 2, then our T is 4, plus our Q is 5 and our S is negative 3 over Q is 5 and our T is 4. Then multiply 2 times 4 is equals to 8 plus multiply 5 times negative 3 is equals to negative 15 over 5 times 4 is equals to 20. So 8 plus negative 15 is equals to negative 7. Then copy the denominator 20. Therefore, 2/5 plus negative 3/4 is equals to negative 7 over 20. Let's move to subtraction. Similarly, if we subtract P over Q and S over T, then also we need to make the denominator same first and then do the subtraction. For example, number 1, 1/2 minus 3/4. So our formula is PT minus QS over QT. Our given or P is equals to 1, Q is 2, S is 3, T is 4. Then substitute the formula. So P is 1, T is 4, minus Q is 2, and S is 3 over Q is 2 and T is 4. Then multiply 1 times 4 is equals to 4, minus multiply 2 times 3 is equals to 6. And 2 times 4 is equals to 8. Then subtract 4 minus 6 is equals to negative 2. Then copy the denominator 8. Then simplify negative 2 over 8 by dividing both sides by 2. So negative 2 divided by 2 is equals to negative 1. And 8 divided by 2 is equals to 4. Therefore, 1/2 minus 3/4 is equals to negative 2/8 or negative 1/4. We have example number 2. So 2/5 minus negative 3/4. Our formula is PT minus QS over QT. So our given are P is equals to, Q is 5, S is negative 3, and T is 4. Then substitute the formula. So our P is 2, T is 4, minus Q is 5, and our S is negative 3 over Q 5 and T is 4. Then multiply 2 times 4 is equals to 8, minus multiply 5 times negative 3 is equals to negative 15. And then 5 times 4 is equals to 20. Then subtract 8 minus negative 15 is equals to 23. Then copy the denominator 20. So 2/5 minus negative 3/4 is equals to 23 over 20. Next, we have multiplication. In case of multiplication, while multiplying two rational numbers, the numerator and the denominators of the rational numbers are multiplied respectively. If P over Q is multiplied by S over T, then we get P times S over Q times T. For number 1 example, 1/2 times 3/4. So our formula is P times S over Q times T. Our given are P is equals to 1, Q is 2, S is 3, and T is 4. Then substitute the formula. So P is 1 times S is 3 over Q is 2 times T is 4. So 1 times 3 is equals to 3 and 2 times 4 is equals to 8. Therefore, 1 half times 3/4 is equals to 3/8. For number 2, 2/5 times negative 3/4. So our formula again, P times S over Q times T. Our given or P is equals to 2, Q is 5, S is negative 3, and T is 4. So to substitute the formula, our P is 2 times our S is negative 3 over Q is 5 times T is 4. So multiply 2 times negative 3 is equals to negative 6 and 5 times 4 is equals to 20. Then simplify negative 6 over 20 by dividing both sides by 2. So negative 6 divided by 2 is equals to negative 3 and 20 divided by 2 is equals to 10. Therefore, 2/5 times negative 3/4 is equals to negative 6 over 20 or negative 3 over 10. Lastly, we have division. If P over Q is divided by S over T, then it is represented as P over Q divided by S over T is equals to PT over QS. So for example, number 1, 1/2 divided by 3/4. So our formula is P over Q divided by S over T is equals to PT over QS. So our given are P is equals to 1, Q is 2, S is 3, and T is 4. So substitute the formula PT over QS. So our P is 1, T is 4, over our Q is 2, and our S is 3. So multiply 1 times 4 is equals to 4. Then 2 times 3 is equals to 6. Then simplify 4 over 6 by dividing both sides by 2. So 4 divided by 2 is equals to 2 and 6 divided by 2 is equals to 3. Therefore, 1/2 divided by 3/4 is equals to 4 over 6 or 2/3. We have example number 2. So 2/5 divided by negative 3/4. So our formula is P over Q divided by S over T is equals to PT over QS. And our given are P is equals to, Q is 5, S is negative 3, and T is 4. So substitute the formula PT over QS. So our P is 2 and our T is 4 over our Q is 5 and our S is negative 3. Then multiply 2 times 4 is equals to 8 and 5 times negative 3 is equals to negative 15. Therefore, 2/5 divided by negative 3/4 is equals to 8 over negative 15. That's the end of our lesson for today. Here's our references. Thank you.